All right, this is part one of the video series connecting your math to your kids' math. And this first installment is going to look at carrying and borrowing, which is what we did when we were in school, versus unitizing. All right, so carrying and borrowing. If you watch the introduction, you saw a funny little video clip of Jenna Bush talking about how they don't carry no ones anymore. If you didn't watch that, you need to go back because it's pretty funny. All right, so it's not that we're not carrying anymore or we're not borrowing anymore. We're just not using that language anymore. So what we're actually doing is we're unitizing. Now, you may not hear your kid or even your kid's teacher use the word unitizing, but it's the understanding of unitizing that's what's happening. Let me explain to you what unitizing is, and that's going to help you as the adult understand the carrying and borrowing language and why we might want to use some different language. All right, so unitizing is the counting and quantity principle that refers to the understanding that you can count a large group of items by counting smaller, equal groups of items from within the larger group. All right, if you've got little kids, you may be familiar with base 10 blocks, okay? So what this concept is to understand, all right, these little unit cubes here, 10 of those make a rod. Okay, and so this rod, this stick, whatever you want to call it, that has a value of 10 of these. And just understanding that if I put 10 of these rods together, then I can make this flat, and that flat has a value of 100. And you can use this with other things besides base 10 blocks. That's just a pretty common manipulative in classrooms. I use popsicle sticks a lot. I'll have kids count out some popsicle sticks, and then we look to see if we can make any bundles of 10. So that bundle of 10, that's when I am helping them unitize. All right, so if they count out 21 popsicle sticks, can we make any bundles of 10? And hopefully they're like, yes, and they understand they can make two bundles. And if not, we count them out and we put a rubber band around them. And that's another great manipulative if you've got a little that's having trouble understanding. All right, so 17. If I'm doing popsicle sticks, I count out 17 popsicle sticks. That's 17 ones. Or if I'm using base 10 blocks, I count out 17 of these units. That's 17 ones. But what unitizing, this concept helps kids understand that while that is 17 ones, it can also be thought of as a 10 and 7 ones. All right, one bundle of 10 popsicle sticks wrapped in a rubber band and 7 ones. Or one of these rods that represents 10 and 7 of these unit cubes. All right, 42. 42 is 42 ones. Nobody's wanting to count out 42 popsicle sticks or 42 of these unit cubes. So we want to get more efficient by recognizing that, yes, it's 42 ones, but we can think of it as 4 tens and 2 ones. 4 bundles of 10 popsicle sticks and 2 loose popsicle sticks, or 4 of these rods and 2 unit cubes. All right, but here's where it gets really powerful. 42 is 4 tens and 2 ones, but it's not just 4 tens and 2 ones. It can also be thought of as 3 tens and 12 ones. Okay, that's still 42. This is a huge understanding for kids in about first and second grade. All right, so, and it's also 2 tens and 22 ones, and 1 10 and 32 ones. All of that is really important with this concept of unitizing. Okay, so while we're trying to get away from this language of carrying and borrowing, and unitizing, I told you, is probably not what you're going to hear your kid or even your kid's teacher saying, but regrouping, I bet, is a word that you've heard and you're like, I don't even know what that means. All right, so let's connect what regrouping means to that carrying that you did or that borrowing that you did when you were in school. All right, 305, and we're going to subtract 143. Okay, so we've got, if you've got a kid who's in end of third grade or fourth grade, they're using the standard algorithm. So they're going to go over here to this ones place and say 5 ones minus 3 ones, that's 2 ones. So they're going to go to this tens place and see this digit 0 in the tens place and realize if I've got to take away 4 tens, I'm going to have to do some regrouping. I need to rearrange my hundreds and my tens. I need to use 2 hundreds and 10 tens so that I can say 10 tens minus 4 tens, well, that's 6 tens. And 2 hundreds minus 100, well, that's 100. 162. So we didn't really think of it as borrowing as much as just rearranging the values, okay, or regrouping the values, or unbundling a mega bundle of popsicle sticks. Whatever kind of language helps the kid understand what's happening there. All right, so regrouping with addition, much the same way. If they're beginning to use the algorithm, they're going to come over here and they're going to say, all right, 7 ones plus 4 ones, well, that's 11 ones. But I can't put 11 ones in the ones place. So I'm going to need to regroup and think of that as 110 and 1 1. That 11 ones becomes 110 and 1 1. And so then I'm going to add 110, 3 tens, and 4 tens. That's 8 tens. 300s and 100. That's 400s. All right, let's see. 283 plus 564. All right, if they're using the standard algorithm, they'll go over here to the ones place and add to get 7 ones. And then they'll go to their tens place, 8 tens plus 6 tens. That's 14 tens. But I can't put 14 tens in the tens place. I need to regroup those tens. I need it to be 104 tens. And then now I can add the hundreds place. 100 plus 200s plus 500s, that's 800s. All right, so why the shift? Now, there are people, scholars, a lot smarter than me that could do a better job of explaining this, I'm sure. But I'm going to give you just, from the boots on the ground in the classroom, why was this shift made? It's because students don't have place value understanding if they think they're carrying a 1. All right, because this 1 here, that's actually 100. And I think there was probably a time long ago that kids understood that. But we got so in the habit of carrying the 1 and also saying 8 plus 6 is 14. Put down your 4, carry your 1. Well, this is 8 tens plus 6 tens, and that's 14 tens. And so because we took a shortcut with our words, over time, we had kids and adults even who really didn't have that place value understanding. Same here with the subtraction. Okay, 0 minus 4, can't do that. Well, first of all, that's 4 tens, but also you can say 0 minus 4, it's negative 4, but we don't want that to happen here. So what we need to do is not so much borrow, but rearrange our hundreds and tens to make this something that we can work with. All right, so that was a lot of meat in a little bit of time, but I hope that some of this will help you connect your math that you learned when you were in school to what your kids are learning in their classrooms today.